This is part B of the AP Physics Special Project, Chapter 10 assignment. I'm James Wigton, period 8. We're going to be doing part B. So part B reads, at a water park, people slide down a water slide where friction is negligible. The top of the slide is 3 meters above the bottom where the exit slide, and they are moving horizontally when they exit the slide. That exit to the slide is a distance h above a swimming pool. If the person lands in the pool a horizontal distance of 4.1 meters from the exit of the slide, how far above the pool is the exit to the slide? So we're looking for h, that's what that's asking for. So let's start by drawing our diagram. So first we go down, we have a little space, and then our little guy is going to jump off into the water. And we're going to call our water level 0. We know the distance from the slide to where they fall out is going to be 4.1 meters. We know this distance is 3 meters. And that is, and we also know that this distance is h. So the first thing we can do is we're going to find our velocity here, which will also be our velocity here because friction is negligible. So let's start by saying our mechanical energy at the initial point up here is going to be equal to our mechanical energy at our final spot. So our initial is going to be only U of G, and our final is going to be only delta K, gravitational potential and kinetic. So then let's just do our equations. Mg delta Y is equal to 1/2 mv squared. Lucky for us, our m's cancel out. From there, we can solve for velocity. Velocity is going to be equal to the square root of 2, so this, times gravity times delta Y. We know all of those things. Let's just plug in. 2 times 9.8, all the way times 3. And from there, we get our velocity of 7.668 meters per second. So we have our velocity here now. Well, we found it here, but it's also here because of friction. So let's see what we can use for kinematics. And I'm just going to skip to the one that we actually need to end up using. It's going to be, and since we're working in the y, we're going to change the equation in terms of y. So we know y final, y initial is equal to y final plus, sorry, other way around. Y final is equal to y initial plus velocity initial in the y times time plus 1/2 a/t squared. So we have our y final, we know y initial is what we're looking for. We know our velocity is 0. We don't have time, but lucky for us, this cancels out. But we still need time because of over here. A is going to be 9.8, it's going to be gravity. So we got to find time. Our time is a super simple equation. D is equal to vt, distance is equal to velocity times time. And that's because velocity is the same as distance over time. So on this side, t's would cancel out, distance equals distance. So our distance is 4.1 here. Our velocity, we just found that, the top here. It's going to be 7.668, and then we have times time. So from there, we get time is equal to 4.1 divided by 7.668, which is equal to 0.5347. And look at that. Now we have time. Let's plug into our equation. So we know our final is going to be 0. It's in the water. It's our 0 level. 0 is equal to our initial. Top up here, it's height h. Plus our velocity initial is 0 times time. And that's going to be plus 1/2. Acceleration is negative 9.8, or gravity, times 0.5347 squared. Right out of the room there. So from there, we can find h. Negative h is going to be equal to 1/2 times negative 9.8 all the way times 0.5347 squared. Our negatives are going to cancel out, and from there we find that h is equal to 1.401 meters. And that's our answer, and we can also logically check this to see that our slide is going to be about 4.401 meters, which makes sense.